Hello viewers, welcome back to our YouTube channel 3D Parametric Solid Model Drawings. Today we are creating the model mechanical bench vise in Autodesk Inventor. In this video, you will learn the full modeling process of this model and its components. We have used 10 part files and one assembly to make this assembly. If you want to get the file of this model, its files are free for available here and can be downloaded easily. We have given the link address in the description of my video. By visiting that link, you can get it easily. Okay, that's it. Now this is the simple bench vise assembly. Each part will be created separately and afterwards all the components placed into the main assembly. Okay, alright. So let's start the tutorial. First of all, we will create the base part. Let's start a millimeter part file from here. Okay, that's it. So let's start the 2D sketch command from here. Okay. Now select the YZ plane from the design window to start the new sketch. Let's make the first part of bench vise, which is named the base part. Now this sketch profile height is 55.55 mm. And the width of this sketch profile is 69.85 mm. Okay. Now this inner slot height is 26.97 mm and the width is 31.85 mm. The top slot height is 15.89 mm and the slot width is 25.40 mm. The diameter of this big circle is 34.90 mm and the diameter of the small circle is 12.19 mm. Now see here, the thickness of this sketch profile is 25.4 millimeters. So I hope that you have understood a little bit from the drawing sheet. So now I am going to make and show you. Back to the part file. Now let me choose corner rectangle tool and make a rectangle from here. Let me choose vertical constraint and select the midpoint of the rectangle line and select the part origin. See, the rectangle is centered here. Let me choose dimension tool and the rectangle width is 69.85 mm and the height of the rectangle is 55.55 mm. Now let me choose the project geometry tool and take the project of XZ and XY plane. Convert these two lines into construction geometry from here. Here I will apply one more coincident constraint between these 2 points so that my sketch is fully constrained. Now let me create another small rectangle inside of the outer rectangle. Height and width of this rectangle is 26.97 and 31.85 millimeter. Now draw one more rectangle over the top of this inside rectangle. And apply the dimension to fix it. Convert the rectangle lines into construction geometry like this. Let me draw the lines on the construction lines to close the sketch profile. Now draw two circles on the top of the sketch. Apply the dimension 1.6 mm between center point of the circle and top line of the rectangle. The outer dia of circle is 34.9 mm and the inner dia of the circle is 12.19 mm. Okay. Now convert this circle into construction geometry. Draw the line from this endpoint and its length is 17.48 mm. Okay, now draw the vertical line and I will trim this line down to this. And now I will create a mirror of these two lines. Draw an arc between the two endpoints to close the sketch profile. Okay, alright, my sketch is fully constrained, so now I am exiting the sketching mode. I am activating the Extrude command from here and select the sketch profile. Extrude this sketch profile in this direction and fill the distance value 25.4 mm as I told you earlier according to your drawing sheet. Okay, that's it. So this is my first extrude feature built in here. So from here I can change the light and color of this part. The color of the part, which is chrome, will remain polished. Save the part with the name base under the mechanical bench Vise folder. Now see here, my part is looking perfect. Now back into the drawing sheet file. Okay, next I will create a sketch over the front face of the feature. The height of the sketch is 39.67 mm and extrude this sketch profile 127 mm. Okay, alright, now back to the part file. Now select front face, sketch. Take the project of the entire model. And convert the entire sketches into construction geometry. Now draw the lines like this. and fix the height 39.67 millimeter. Finish the sketch. Extrude this sketch 127 millimeter. Now I am creating a mirror of this extruded feature on the opposite side. Next, I am applying the fillet on these two model edges. The fillet radius is 6 mm. Apply another fillet over the 4 more model edges, but this time the fillet radius will keep 3 mm. Okay. Next, I will create a sketch of the front face of the model. The height from here is 44.45 mm. Then extrude it 31.75 mm. Okay, now select the front face, sketch. Take the project of the entire face and convert the sketch lines into construction geometry. Draw a rectangle. And set the distance value 44.45 mm between these two lines. Draw the lines on the projected sketch like this. Mirror the sketch lines on the opposite side. Okay, finish the sketch. And extrude this sketch 31.75 mm. Okay, that's it. Next, I will create a sketch on XZ plane. Let's make an arc here. Its radius will keep 34.93 mm. And add the dimension 30.15 mm between this endpoint to this endpoint. After creating this, I will remove this sketch with the help of Extrude feature. Well, after making this feature, I will create 4 legs in the base part, the dimensions of which I have given here. Now this circle diameter will keep 56 mm and the inner circle diameter will keep 8 mm. The center distance of the circle 15 mm from the outside edge. Okay, alright. The height of leg will keep 8 mm. And leg of the corner fillets will keep 6 mm. The extrude feature of the leg will remain the same, and after that 3 more will be created with the help of mirror tool. Okay, now let us create a sketch on XZ plane and choose the slice graphics option from here. Now let me choose the project cut edges command from here and convert the entire sketches into construction geometry. Draw an arc on here. The radius will keep 34.93 mm. The vertical dimension will keep 30.15. Okay, now draw the 2 lines as the same to close the sketch profile. Finish the sketch. Now let me cut this sketch profile on both sides from the midplane. Now see. Now let us create another sketch on XY plane for creating its leg. Now rotate the model on backside. Draw an arc on here. And now create a circle. Okay. Fix the vertical constraint between the center point of the outer arc and the inner circle. Next, let's fix the coincident constraint between the center point of the arc and the outer projected edge. Let's fix the dimensions on the outer arc and inner arc. Finish the sketch. And extrude this sketch 8 mm. Now see, my first leg is made here. I will mirror this feature, activate the mirror feature command and select this extrude feature. Many options are given here, out of which you can make a mirror by selecting by anyone. Okay, now let me choose here XZ plane. Now see, my 2 legs are made. Now I am going to make a new work plane here, which will be made in the middle of the part. With the help of this plane using the mirror tool, I am going to make two more legs. Now activate the work plane command from here and select the front and back face of the part. Okay, now see the result. Now activate the mirror tool once again and select the solid features and work plane. Okay, now see my four legs are made. Okay, that's it. Now I will apply the fillets to the edges of the legs. The fillet radius is 6 mm. Now I am going to make a 3 mm fillet here on the outside edges of the part. Okay, alright, my base part is looking perfect. Next, I will make two tapped holes on the jaw face of the base part. This is an ANSI unified screw thread. The designation is 1 by 4-20 UNC. And the hole depth is 22.35 mm. The thread depth is 16 mm. The location of the holes is shown in the drawing sheet. The distance value of 25.40 mm between the center point of the hole and this edge. Okay, the second value of 15.80 mm between this center point of the hole and the side edge. The distance value between the two holes will keep 38.10 mm. Okay, that's it. So let's start the sketch over the jaw face of the base part. Now I will make two center points here and apply the vertical constraint between these 2 points. Now I will give the dimensions to fix it. Okay, finish the sketch. Now I activate the hole command and it will automatically select the sketch points. Now I select the tabbed hole option and select the 0.25 value from the thread size list. Now fix the thread and hole depth values and click OK to create the hole. Okay, alright, now see my holes are created here. Now I will give a chamfer on this whole edge. The chamfer distance is 2 mm and the angle is 45 degrees. Now I will apply some more fillets on the model edge like this. Next, I will create a realistic thread with a sketch profile over the inside of this hole by using the coil tool. So let's start. First, I will create an axis of this hole. And make a work plane by selecting this axis. Now I am starting the sketch on this plane. Activate the project cut edges command from here. Okay, now see the entire projected curves has been created here. Convert the entire projected curves into construction geometry. Let me draw a thread sketch profile like this. Its height is 1.84 millimeter. And apply the symmetric constraint between these two aligned lines and the center line. Set the angular dimension 28 degrees between these two aligned lines. And the bottom line dimension will keep 1.37 millimeter. Fix the horizontal constraint between this endpoint of the line and this edge point. And fix the coincident constraint between these two endpoints. Okay, alright. Finish the sketch. So now I am activating the coil tool from here. It will automatically select the thread sketch profile. Let me select the axis. Okay, choose the cut option because I do the cut here. Okay, go to the coil size tab. Here I will give the pitch value 3.5 mm and set the revolution 10. Okay. Now see, my realistic thread is looking very nice. With this, my base part has also been completed here. So now I am closing this part file. Now I am creating the next part, Vise Extrude. Okay, let's see its drawing sheet file. The total length of the screw will keep 160 mm. Now see, in the left side, this radius will keep 9.50 mm. And this dimension from here to here is 20.65 mm. This slot distance is 6.35 mm. And the height will also keep 6.35 mm. The edge of the screw radius will keep 1.5 mm. This dimension from here to here is 100 mm. C in the right side dimension will keep 23.30 mm. This slot horizontal dimension is 3.35 mm and this slot vertical dimension is 4.75 mm. See, in the section view, the whole diameter will keep 8.75 mm. The circle will be placed over the center of this feature. The sketch profile of its thread and where to keep it, I will tell you during the sketching of the part. The sketch profile of the thread will be the same as I showed you earlier. So let's start. Now create another new millimeter part file. And start the sketching on the exit plane. Take the project of XY plane and convert the projected line into construction geometry. Now draw a rectangle on here and fix the coincident constraint between the midpoint of the rectangle line and the part origin. Its length is 160 mm. Now this length is 9.5 mm. Draw the lines over the rectangle like this. Now this length is 20.65 mm and this length is 6.35. Now this length will also keep 6.35 mm. Okay. Now this line length is 100 mm. Convert the outer rectangle line into construction geometry. And draw the line over the rectangle like this. Now we will fix the dimension on this line 1.6 mm. Okay, alright. Now go to the right side the sketch. Now draw the lines like this. and fix the dimensions to fully constrain the sketch. Select the baseline and convert this line into center line. So now my sketching is completed here. Okay, now I am activating the Revolve tool. The sketch will be automatically selected here and click OK. Change the part color as chrome polished. Now see, my part is looking perfect. And save the part with the name Vise Screw. Now we will apply the chamfer on this edge. The chamfer distance value will keep 1.5 mm. Now we will apply the fillet on the opposite side edge. Okay. Next, I am starting the sketch on XY plane. Take the project of the entire model. Okay, now I am creating the thread sketch profile here. Okay, I will apply the same dimensions on this sketch as I had done earlier in my previous model. Okay, finish the sketch. Open the visibility of x-axis. Now I am activating the coil tool from here. See, the sketch will be automatically selected. Next, I will select the x-axis. Choose the reverse direction button and select the cut option. Now go on the coil size tab and fix the pitch value 3.5. And fix the revolution value 29.25. And click OK. Now see, my thread is created on the cylindrical surface. It is looking very nice. Next, I will make a hole on the center of this face. The hole diameter is 8.75 millimeter. Now activate the extrude command and select the sketch. Choose the symmetric option. Drag the arrow button like this and click OK. Now see, my hole is created. Okay, my part has been completed here. So now let me talk about making my next part. My next part is sliding jaw. This is also a main part of this assembly that I am going to make. See the drawing sheet here. The base is sketch dimension is here. Now see, this rectangle dimension is 69.85 mm by 44.54 mm. Okay, this vertical dimension will keep 38 mm. Now this dimension from here to here is 12.88 mm. This slot width is 5.56 mm. Okay, the slot height is 4.78 mm. Now this dimension from here to here is 25.40 mm. Okay, that's it. Here I will also make the two tapped holes on the face of the sliding jaw part. The hole will be made in the same way as earlier I made the hole in my base part. The location of the holes is shown in the drawing sheet. The distance value of 25.40 mm between the center point of the hole and this bottom edge. Okay, the second value of 15.88 mm between this center point of the hole and the side edge. The distance value between the two holes will keep 38.10 mm. Okay, that's it. After creating this, I will create a taper sketch profile on its side face. The dimension is given below. Now this horizontal dimension is 65 mm and its height will keep 34.93 mm. The angular dimension is 74.7 degrees. Okay. See here on the top side, this arc radius will keep 34.93 mm. This dimension is 8.54 mm from the side edge and the end of the arc. Now this vertical dimension is 25.54 mm and this line dimension is 14.71 mm. This inner fillet radius is 6 mm. The outer edge fillet will keep 3 mm. And the fillet of the outside model edges is 0.5 mm. So come first, I am going to make it and I will tell you the dimensions of the rest of the features later. Okay, that's it. So let's start. Open a new millimeter power file from here. And start the sketching on XZ plane. Draw a rectangle on here and fix the vertical constraint between the midpoint of the rectangle line and part origin. Draw another rectangle on the bottom side and fix the vertical constraint between the midpoint of bottom rectangle line and part origin. The top rectangle width and height will keep 69.85 by 44.54 mm. Take the project of XY plane by using the project geometry command and apply collinear constraint between these two lines. Now convert these two lines into construction geometry. Draw the two lines on this rectangle. Now this line length is 38 mm and this line length is 25.4 mm. Okay, that's it. Now I will create two more rectangles on here. Fix the equal constraint between these two top rectangle lines. Okay, and fix the dimension 12.88 mm on this line. The height of this small rectangle is 4.78 mm. I will convert the outer lines into construction geometry. And draw the lines something like this over the projected line to close the sketch profile. So now my sketch is completed here. Finish the sketch. Activate the extrude command and select the sketch. Extrude this sketch 40 mm. Okay, that's it. Now I am changing the part color from here. And save the part with the name sliding jar. Now I am going to create a new sketch over the side face of this part for creating a cylindrical surface. Now take the project of this face and convert the entire projected sketches into construction geometry. Draw an arc and create the lines over this face like this. Now this vertical line dimension is 25.54 millimeter and this horizontal line dimension is 8.54 millimeter. The arc radius will keep 34.93 millimeter. Fix the dimension 14.71 millimeter between these two endpoints. Okay, that's it. Now I will cut this sketch profile by using the extrude command. Okay, now see the result. My cut feature is looking perfect. Now I will apply the fillet 6 millimeter on this edge. Here I will create another extrude feature on this face. And later I will create a tabbed hole over this extrude feature. Now see here its dimension is given in the drawing sheet file. The arc radius will keep 17.46 millimeter and the arc height is 15.86 millimeter. Arc will be placed in the center of the total part. The tabbed hole dimensions will keep 7 by 8-9 UNC. Thread depth will keep full depth and the hole depth is 30 millimeter. Okay, alright, so I am start the sketching on the front face. First of all, I will take the project of the entire model edges and a Vise plane and convert them into construction geometry. Draw an arc on here and create a sketch point over the midpoint of the arc. Fix the coincident constraint between this point and vertical projected line. Now see my arc is placed on the center of the part. I will fix the dimension over this to fully constrain the sketch. Okay, finish the sketch, activate the extrude command, select the sketch and choose the reverse direction button. Here I am selecting the two next option and click OK. Now see my extrude feature is created here. Okay, now I am applying the fillet 3 millimeter on this arc edge. and this outer edge. Now see, my part is looking perfect. Now I am going to create another sketch over the side face of this part for creating an aligned face. Now take the project of this face and convert the entire projected sketches into construction geometry. Draw a sketch profile like this. Now this vertical line dimension is 34.93 millimeter. And this horizontal line dimension is 65 millimeter. Now fix the angular dimension 74 degrees between these two lines. Okay, finish the sketch. Now I will extrude this sketch up to the opposite side face. See, my taper face has been created here. It is looking very nice. Now rotate the model and start a sketch on this face. Take the project and draw two rectangles over this. Now we will cut this sketch profile through all over the body like this. Activate the whole command from here. Choose the concentric option. At first select this face and then next select this curve edge. Now activate the tabbed hole option from here. Thread size and designation is selected here. Thread depth is full and hole depth is 30 mm. On its face, I am going to make two more tabbed holes like I showed you earlier in my drawing sheet. Now my tabbed holes are created on this face. Next, I am making two more holes on the bottom side of this part, the details of which I have given on my drawing sheet. You can see from here. The 30mm dimension will keep between the bottom edge and hole center point. The 15.88mm dimension will keep between these two holes. First of all, I will make the two simple holes, and afterward I will create an ANSI unified screw thread over the simple holes. The designation is 12-24 UNC. The thread depth is 19mm and the hole depth is 24.5mm. Okay, now I am starting the sketch on the bottom face. And create two sketch points with the given dimensions. Finish the sketch. Now activate the hole tool. Choose simple hole option. The hole depth is 27mm and the diameter is 3.79mm. And click OK. Now activate the hole tool once again. And select the tabbed hole option from here. Choose 0.216 value from the size list. Fix the thread and hole depth values from here. In the same manner, create one more tabbed hole. Okay. Okay, that's it. My holes are created on the bottom face. Now I am applying the fillets on the outer model edge. The fillet radius is 0.5mm. Okay, now my sliding jaw part is looking perfect. Now this part is completed here, so close the part file. Now I am creating some miscellaneous parts of this assembly. I am going to tell you about this by demonstrating directly. I have not shown its dimension in the drawing sheet. First off, I am creating a small part, slide key. Okay, so let's start. Start the new part file from here and start the sketching on XZ plane. Now draw a center point rectangle over the part origin. The width and height of the rectangle will keep 60 by 8.64 mm. Now create another rectangle on here and fix the constant constraint over this. Now this rectangle width and height is 4 by 3.25 mm. Convert the top rectangle line into construction geometry and draw the lines over the construction line. Okay, alright, finish the sketch. Now extrude this sketch profile 4.75 mm. And save the part with the name slide key. Now close the part. Open another new part file from here. Now I am creating its jaw plate. Okay. And start the sketch on XY plane. Now draw a center point rectangle over the part origin. The width and height of the rectangle will keep 69.85 by 44.45 mm. Okay, and extrude it 5 mm. Okay, that's it. Change the part color as chrome polished. Now rotate the model in this position. And save the part with the name jaw plate. Next, I am creating the two counter bored holes on this face. Now select this face, sketch. Now create sketch points for creating the holes. Fix the horizontal constraint between these 2 points. Now select this point and the bottom edge and apply the dimension 25.4 millimeter. Fix the dimension 38.1 millimeter between the two sketch points. Take the project Vise plane and fix the symmetric constraint over this. Okay, finish the sketch. Now activate the hole tool from here. Choose the counter bore option. Counter bore diameter is 0.47 and its depth is 0.14. The hole depth is 24.5. And the diameter of the hole is 0.266. All the dimensions will keep in inches. And click OK to create the hole. Now it is looking perfect. I am applying the fillets on the outer edges of the part. The fillet radius is 0.5 millimeter. Okay, alright. Next, I am creating a realistic knurling on this jaw face. Now select this face, sketch, and take the project of the entire face. Now convert them into construction geometry. Draw an aligned rectangle like this by using the line tool. And fix the parallel constraint between these aligned lines. This rectangle line width is 1 millimeter. Now I am fixing the position of the rectangle something like this. And apply the dimension 1 millimeter between this endpoint of the rectangle line and the bottom edge point. Apply the dimension 5.8 millimeter between the bottom edge and this endpoint of the rectangle line. Select this line and select the aligned line and fix the angular dimension 135 degrees. The height of the rectangle is 79.56 millimeter. Now my sketch is fully constrained on here, so I am creating the rectangular pattern of this sketch profile. Now I am activating the rectangular pattern tool from here. Select this rectangle. Okay, now select the bottom edge of the part for defining the pattern direction. Now fix the pattern value 50. Fix the pattern spacing value 3 millimeter and click OK. Okay, now see my sketch pattern is created here. So now finish the sketch. Now I am activating the extrude command and select each rectangle one by one like this. Okay, now select the reverse direction button. Choose the cut option. Go on the more option and fix the taper distance value minus 15 degrees. Now zoom the feature like this for checking the taper distance direction. If its direction is wrong, then you can change the taper distance value to plus or minus and click OK. Now see my first mirroring is created. Next, I will create the mirror of this cut extrude feature on the opposite side of the part so that its taper is converted into a triangle. Now I am activating the mirror tool from here and choose the cut extrude feature from the browse bar. And now select the origin Vise plane and click OK. Now see the result. My realistic knurling has been successfully generated here. It is looking very nice. So now my part is completed here and close the file. Here I am creating a collar part. Now open a new part file. Now select the XY plane, sketch. Draw the two circles from the part origin. One circle diameter is 13 mm and the second one is 18.24 mm. Now finish the sketch. And extrude this sketch profile 20 mm. Change the part color as brass satin. Okay, now my part is looking perfect. Now select the front face, sketch. Draw a center point rectangle on here. Its height and width is 20 mm by 2.36 mm. Finish the sketch. Now I will 3.25 mm deep cut this sketch profile from the front face. Now save the part with the name collar. Close the part. Next, I am creating a part named special key. Now open a new part file. Select the XY plane, sketch. Draw the two small lines on here like this. And take the project of Vise plane. Now I will fix the symmetric constraint between these two lines by selecting the center line. Okay, alright. Let's draw an arc between these two lines. And fix the coincident constraint between the arc midpoint and part origin. Now I am fixing the tangent constraint between this arc and the vertical line. The radius will keep 5 mm. And the line length will keep 7.63 mm. Now create another arc between the endpoints of the vertical lines. The center of both the arcs will be the same here. Okay, that's it. Finish the sketch. And extrude this sketch profile 3.25 mm on both sides from the center plane. Save the part with the name special key. And close the file. Create another new part file from here. And start the sketch on Vise plane. Create a circle of 8 mm diameter. And extrude this circle 120 mm on the both sides from the center plane. Save the part with the name handle rod. Now close the file and create another new part file from here. And start the sketch on exact plane. Draw a vertical line and fix the line over the part origin by using the coincident constraint. Create an arc on here. This line length is 19 mm. And the arc radius is 9.5 mm. Okay, finish the sketch. Now I am activating the Revolve tool from here and revolve the sketch profile. Start the sketch on XY plane and take the project of the outer edge. Create a circle 8 mm diameter and extrude this circle 29.25 mm on both sides from the center plane. See here, the hole is made. Save the file with the name handle ball. Now I am creating another small hole on its side face. The hole diameter is 2.64 mm. The part has been completed here, so close the file. Now I am creating a small pin here, and this is the last part of my bench-wise assembly. After that, I will create the main assembly. Okay, alright. Start the sketching on XY plane and take the project of YZ plane and XZ plane. Convert the projected lines into construction geometry. Create two horizontal lines like this. The bottom line length is 8 mm and the top line length is 7.2 mm. Create two vertical lines from here and its length is 1.14 mm. Fix the dimension 1.25 mm between these two lines. And create two more lines to close the sketch profile. Okay, now I will revolve this sketch. And change the part color. Save the part, name it as pin. Close the part file. Okay, that's it. Finally, all the part files of the bench-wise model are finished here. So now I am creating a new millimeter assembly file in Autodesk Inventor. Okay, that's it. Now my assembly design window is visible on your screen. First of all, I am activating the place component command from the component panel. Okay, now I am selecting the base part that I created first. Alright. And place the base part in this assembly by choosing the place grounded at origin option. Okay, this time my assembly is fully constrained. Here, no need to give any mates over this part because this part is grounded. Save the assembly with the name mechanical bench Vise. Click save. Now I am choosing the part color of the part as cyan. Change the light of the assembly from here. Now see, my assembly is looking much better. Now I am activating the place component command and insert the part jaw plate on here. Okay, now I will rotate the jaw plate in this position. Now I will activate the constraint command from the relationships panel. In the place constraint dialog box, the mate constraint will automatically be selected by default. Now I select the back face of the jaw plate and the whole face of the base part. Okay, and apply the mate constraint between them. Okay, alright, now I am selecting the flush mate option from here and apply the flush mate between the top face of these two parts. Now I am applying another flush mate between the side face of these two parts. Now see here, my jaw plate has been successfully placed over the base part. Now I will insert the sliding jaw part in this assembly. Rotate the sliding jaw 90 degrees along the Z-axis in the following way. I will also change the color of the part. From here, I will increase the brightness of the assembly. Okay, alright, it is looking very nice. And now I am inserting one more copy of the jaw plate part in this assembly. And fix the jaw plate over the sliding jaw part by using the assembly mates, like this. See here, the jaw plate has been properly fixed on the sliding jaw part. Next, I am inserting the slide key in this assembly. Okay. And rotate the part in this position by using the free rotate command. Now activate the constraint command, select the inner slot face of the sliding jaw and select this inside face of the slide key and apply the mate constraint between them. Now select this one and this one and apply another mate constraint between them. Okay, that's it. Now choose the flush mate option. Select this one and apply the flush mate between them. In the same manner, I fixed the second slide key on the opposite side slot of the slide jaw. Now rotate the sliding jaw in this position by using the free rotate command. Activate the constraint tool once again Now choose the flush mate option and apply the flush mate between the side face of the sliding jaw and base. Now choose the mate constraint here and apply the mate constraint between the top face of the base and the back face of the sliding jaw. Okay, now see, my sliding jaw is perfectly running over the base. Next, I am inserting the Vise screw in this assembly. Okay, alright, activate the constraint tool. Now select the axis of Vise screw and then next select the whole axis of the base part and apply the mate constraint between them. Drag the Vise screw like this. Okay, alright, insert the Vise handle in this assembly. Now select the axis of the handle and next I will select the whole axis of the Vise screw and apply the mate constraint between them. Now I will fix another mate constraint between the YZ plane of the handle rod and XY plane of Vise screw. Choose the front view and rotate the handle like this. See here, my handle is fixed over the center of the Vise screw. Now activate the constraint tool and choose the angle mate from here. Select the directed angle option. Now I will fix this angle mate between the XZ plane of handle rod and XZ plane of the Vise screw. Now I will insert the handlebar part on here. Fix the mate constraint between the whole axis of ball part and handle axis. And I will apply the angle mate between the YZ plane of the handle ball and XY plane of handle rod part. Now I will fix the mate constraint between these two center points of the parts. Okay. Insert the pin in this assembly. And fix it over the whole of the ball in the following way. In the same manner, I will fix another copy of handle ball and pin over the opposite side of the handle. Okay, that's it. My both the parts are fixed over the handle of the vise. So now I will insert the collar and special key part in this assembly. And both the parts will be fixed over the vise screw by using the axis mate in the following way. Fix the flush mate between the front face of these two components. Okay. Fix the mate constraint between the front face of the base part and back face of the special key part. Now I will set the mate offset distance value 0.1 mm and click OK. Now drag the screw part in upward direction. Fix the mate constraint between the slot face of vise screw and top face of special key part. Now drag the vise screw to check the mates. Now see here, my vise handle, screw and sliding jaw are perfectly working here. So now I am inserting the screws from the Inventor Content Center library files. Now activate the Place from Content Center command. And select the slot pan head screw from the Content Center library. Okay, now select the whole face of jaw plate for placing the screw. As soon as I selected the first hole here, another screw is automatically installed in the second hole. Here I will change the screw size, select the screw and right click, choose change size option. Then I select the M5 from the thread description table. The nominal length value of screw will keep 25 mm and click OK. In the same way, I will change the size of the second screw. Okay, that's it. See here, my two screws are properly fixed over the jaw plate. In the same manner, I will fix the two more screws on the opposite side jaw of the plate by using the Place from the Content Center command. Okay, that's it. Now rotate the assembly in backside. Here I will insert two set screws over the hole. Now activate this tool and select slotted headless set screw from the list and place the screw on this hole. Here I will change the size of this screw. I select the #8 from the thread description table and click OK. Now you can see my slotted headless set screws are properly fixed on the base part. Okay, that's it. Now I am dragging the jaw plate and rotating the Vise screw like this. See here, it is perfectly running on the base part. It looks great. I will make a separate video later on how to animate this assembly with dynamic simulation, which you will be able to see on my YouTube channel. Finally, my mechanical bench Vise assembly has been completed here in Autodesk Inventor. I hope you will enjoy this video. If you may like this video, please like and subscribe to my YouTube channel. Please share this video with your friends and colleagues. Okay friends, goodbye.